Okay. Happily, this math is not new. This will work in exactly the same fashion with reversed equations as when we did this for capacitors. Suppose I have some arrangement of resistors. R1 has a resistance of 2 ohms, R2 has a resistance of 3 ohms, R3 has a resistance of 4 ohms, R4 has a resistance of 8 ohms, and R5 has a resistance of 12 ohms. Now, if I want to find out, and let's say that delta V AB is 24 volts. Okay. Again, our steps are to collapse this down. For example, and I can do this in a number of different orders. That's one thing we're going to find, especially as we go into this material. There is no magic order to do things. If you collapse, hey, you take R1 and R2, put them together first. Who cares? Doesn't matter. There are a number of different ways to approach any of these. Mine is one way. If there's another way that works for you, that gets you to the correct answer, work it that way. That's just fine. Now, if I have two resistors in parallel, then R45 is equivalent to, let's see, 1 over R45 is equal to 1 over 8 ohms plus 1 over 12 ohms. Again, I am not going to remove this 1 over 4 or this 1 over R. I'm not going to remove the units because it's the least little work, but it can save so many wrong answers. One thing I'm going to do, because of the limitations of space, is I'm going to unfortunately write over myself a couple of times here. Okay, 8 and 12, the lowest common denominator I see is 24. So 1/12 is 2 24ths. 1/8 is 3 24ths. 1 over the equivalent resistance is 5 over 24 ohms, or the equivalent resistance between thing 4 and thing 5 is 24 fifths, or 4.8 ohms. So that 4.8 ohms. Pause here if necessary. Cool. Now, if I want to take this side and find the equivalent resistance at the bottom, they're in series, they simply add together. The equivalent resistance here is 8.80 ohms, and the equivalent resistance up top is equal to 2 plus 3, 5 ohms. So this becomes 5 ohms and 8.8 ohms. Now, 1 over 5 ohms plus 1 over 8.8 ohms is equal to 0.3136 over ohms. So the total equivalent resistance is 3.188 ohms. Keep an extra significant figure for doing the internal work. Now, that means that the current is equal to delta V over R. So that times 24. So I have a current of 7.527 amps. Now, that current has to split. So, I know the change in potential. Well, the change in potential over, for example, the 8.80 ohms, that's 24 volts. So, delta V is delta V over R. So 24 divided by 8.8 is equal to 2.727 amps. 24 divided by 5 is equal to 4.8 amps. So in terms of, again, the current through resistor 1 and the current through resistor 2, both have to be 4.8 amps. The current through resistors 3 has to be 2.73 amps. The current through resistor 4 and 5, okay, these split. Now, I look at this, and again, it's finding a way to take the accordion out. I know the current at this point must be 2.73 amps. Therefore, I know that delta V over resistor 3 has to be 10.9 delta V3 is 10.9 volts. Which means the change in potential over 4 and over 5 must be what's left between 10.9 and 24, or 13.1 volts. Let's see, I know that delta V equals IR up on the top, and I know the current through both of the ones on the top is 4.8 amps. And so here, 2 times 4.8 is 9.6 amps. 3 times 4.8 is 14.4. Whoops, not amps, how foolish, it should be volts. Volts. Hey, those two add together to be 24 volts. Awesome, we're checking ourselves. I have not randomly screwed up. So now I just need to find, now that I know that the current in I4 and I5 will join together and be 2.73 amps, but I can find out, okay, I know that this is 13.1 volts. So the current through R4 is delta V over R, 13.1 divided by 8 is 1.64. $13.1 divided by 12 is 1.09. Oh, look, let's double check ourselves. 1.64 plus 1.09 add up to be 2.73. So this 2.73 amp current breaks into a 1.64 amp current and a 1.09 amp current, and hooray, everything tracks successfully.